Well, thank you, everybody. You're in for a real treat today. Those of you who stuck around for the last fireside chat of the day, it's great to be here in Las Vegas, here at Mobile World Congress, and we're pleased to have you make it a priority to hear more about MITRE, 5G, security, and work in the test bed. It's my pleasure. I'm Tom Sawanobori. I'm the Chief Technology Officer for CTIA, and it's my distinct pleasure to introduce to you Dr. Charles Clancy. As was stated, he's a Senior Vice President at MITRE. What we may not know about Dr. Clancy, he's a successful researcher, innovator, executive, and entrepreneur. So welcome to the stage, Dr. Clancy, and maybe tell us a little bit, just to get started here, tell us a little bit about your career, how you got started with NSA and your work for Virginia Tech, and how you ended up over at MITRE.
So thanks for the invitation. It's great to be with everyone today, and we've got I think MITRE is here in full force as part of the rollout of our FIGHT framework, which we'll talk about a little bit later. So I'm a Senior Vice President at MITRE, where I lead the sort of science technology half of the company. I got there through a variety of steps in my career. I started my career at the National Security Agency, leading research programs in wireless, big focus on cellular and wireless and mobility. Then I became a professor, which was an awesome 9 years at Virginia Tech, very involved in helping stand up the Hume Center for National Security and Technology and the Commonwealth Cyber Initiative, which has a booth down on the expo floor as well. And then 3 years ago, joined MITRE and now lead MITRE Labs. And lots of fun along the way. So, but I'd say every facet of that's been around sort of the intersection of innovation and mobility.
That's fantastic. So the last panel, we had operators here from the US, we had network suppliers, technology companies. MITRE's a little bit different. So tell us a little bit about MITRE and how you all look at 5G technology and security and maybe some of your interests where you intersect with government.
Yeah, so MITRE is a nonprofit. Most haven't perhaps heard of us unless you're very involved in the federal space. But we're a nonprofit that operates federally funded research and development centers, or FFRDCs, as it just rolls off the tongue. We operate 6 of them for pretty much every corner of the executive branch. And through those FFRDCs, we bring sort of deep scientific expertise to the government. So it's a combination of research and development, prototyping, systems engineering, acquisition support, and policy, really to help the federal government shape its requirements and figure out what to buy and make sure it's acquiring and deploying the right things and developing the right policies. And so each of the different agencies we work with, it's sort of a different mix between sort of the R&D end of the spectrum, the policy end of the spectrum, but it's really about helping inform them to make sort of technically sound engineering decisions around the complex issues that face the nation. So telecommunications is just one of many different topics we work on. But when I joined MITRE 3 years ago, of course, it's a passion area of mine. So I made sure that we really doubled down on the activity in the space, particularly as 5G was becoming more sort of present. And also as the federal government, I think 3 years ago, was struggling to really develop a strategy around 5G. Lots of different pieces of the government pointing in different directions. And at MITRE, we really decided that we needed a whole of government, an ultimately whole of nation approach to 5G. And so we've been working closely with our sponsors across the landscape to try and help knit all that together.
Yeah, it's been really fascinating because I think for the first time in my wireless career, the federal government has taken an extreme interest in wireless technology. I think 3G and 4G occurred, and most of that happened without them getting really involved. But I think they heard a lot of the use cases, the security benefits, the benefits of lower latency, the higher speeds, and then capabilities like network slicing coming along. So what is it that you think it is about 5G? Was it something in particular about 5G that made the government get interested, or do you have a perspective on that?
Certainly, I think there's always 2 sides of each coin with the government. One side is really trying to advance the economic interests of the nation, make sure that our industry is healthy and is able to compete on a global stage. So there's a lot of programs around really looking to fortify the telecom industry in the U.S. as sort of the ability to project influence globally. Other side of that, of course, is that the federal government is a potential user of the technology and has its own use cases and requirements. And so these kind of two things interweave depending on which sponsor you're talking about. I don't know that I think it's indicative of many of the emerging technology areas that really deal with computing. So, for example, Eric Schmidt has a nonprofit he launched that's a follow-on to this big AI commission, and they recently rolled out a whole roadmap and framework for emerging technologies. And so they kind of lumped together really AI and computing, semiconductors, and 5G as really sort of the digital future for the nation and really the focus for the next 5 years. And then they wrap around that biotechnology and smart infrastructure and things like that as sort of later things that we really need to build out and compete. But I think it's really it's sitting at the middle of connecting together AI, computing, and 5G, the communications fabric. So those things all come together and become very important strategically to the United States, both in terms of economic competitiveness, but also as a user of those technologies are going to be front and center for every single federal agency.
That's great. Well, people may not know, but you've been an advisor and a participant in the CTIA Cybersecurity Working Group as a researcher and doing evaluations for us. But now you've been over at MITRE 3 years. How did MITRE get involved with the 5G security testbed? I mean, we heard from the panelists earlier that all of their work and interest in where they see it going, but where was the brainchild for getting involved with this?
Well, it's sort of a perfect role for MITRE because it fits kind of a couple criteria. One, it leverages the fact that we're really this unbiased, neutral entity whose role is really to kind of sit in the middle and cross-connect across. It's a technology area that was one of the ones I mentioned before that is really important to the nation. And it allows us to kind of leverage our knowledge of the inner workings of the federal government and what their priorities are with that of industry. So really helping bring together the technical underpinnings of the testbed was really a sweet spot for us. I think the only challenge for us, though, is we didn't have a federal single sponsor coming to us, writing a check saying, we want you to go do this. So it was a lot more of a sort of take a leap and sort of see the business model come together. But we, of course, host the core network, the standalone core, and the non-standalone core, and have really helped with the architecture, design, and operations of it. So again, it's really a sweet spot for us in sitting as a connector between federal government requirements, industry, and the core technology area.
Yeah, that's great. And you've made significant investments in that lab and have the security resources and the capabilities there. So that's fantastic. And then, so we heard the previous panel talk a little bit about, we're using real world 5G network equipment, which is great. And we're starting with, Ericsson is one of those key platforms. Where do you see things going in the future? Do you see different combinations? People talk about O-RAN, interoperability with other cores. What do you think is the most important? And maybe, where do you see some possibilities there?
So I think there's a lot of different threads that we could follow. And obviously, we don't collectively have the energy to follow them all simultaneously. So there's a little bit of prioritization, I think, that's necessary. Right now, it's primarily focusing on understanding sort of the systems engineering of security for a single vendor network. That's hard enough, as we've discovered, as we've really looked to build it and test it and do the things we've done so far. From there, obviously, you'd want to then start adding vendor heterogeneity, so be able to roam and federate with other cores, either cores that are part of the test bed, or, there are federal sponsors, federal agencies who are building their own test beds, then maybe there's an opportunity to roam directly with them and get some vendor heterogeneity. I think there's a lot of different models that we could explore. I think as we take that a step further to O-RAN, right, talk about ultimate vendor heterogeneity, that's the kind of the whole point of O-RAN is to support that diversity. So again, I think that's something that should definitely be part of the roadmap, given, I'd say, the growing policy emphasis in the United States on O-RAN as sort of a uniquely North American flavor of 5G, and something that I think strategically we want to see continue to grow globally.
Right. Open RAN is kind of an interesting area because some of the operators are deploying that, primarily Dish here in the US and then Rakuten over in Japan. And depending on who you talk to, Open RAN could be more secure or could have certain vulnerabilities. Do you have a perspective on that from the outset? Yeah,
I think, one, as we heard, I think in the prior panel, there's sort of all this discussion about, how secure is 5G? Right, I think the sort of throwaway talking point is, right, 5G is the most secure standard ever developed. We still need to see the implementations be as secure as the standard can allow, right? And I think that's a lot of what the security test bed's looking to evaluate. I think O-RAN is similar, right? So 5G adds a whole bunch of complexity in order to gain all sorts of new features. O-RAN similarly has a lot more complexity, right? You've got all these new what previously were internal interfaces inside of a vertically integrated base station, now exposed so that they can interoperate with different pieces of equipment from different vendors. So with that complexity comes a larger threat surface, right? And I think we just need to be able to manage the risks associated with that threat surface, which comes down to really testing and evaluating the integration and security of the sort of integrated systems. And I was actually just visited Dish's ops center in Denver just yesterday, and got to see their SOC, right, where they are running security operations on sort of nationwide O-RAN deployment. And I mean, they figured it out. So I'd love to see more of the industry sort of dive in and see and do what they've done so far.
That's great. So we're actually building on, as you said, 5G is the most secure technology we've deployed. We built on that. Advances over 4G, and then demonstrating that in the security test bed, see those key features like network slicing and so forth, MZ protection and that sort of thing. But then we have other things to consider, like possibly Open RAN. So yeah, that's pretty cool. Do you?
Well, to the last comment, the last question of the last panel, right? I don't know that will ever be done. There's always going to be the next layer of technology to explore in the test bed.
And do you see, with MITRE's interactions with other government agencies, the Department of Defense or other agencies, do you see them potentially bringing either use cases or certain capabilities that they want to have evaluated in the test bed?
I mean, that's the hope, is that as certain use cases are more defined within different government agencies, we'll be able to explore those, right? So you can imagine. Certainly, the military has a range of different use cases that they're prototyping and experimenting with right now as part of the Pentagon's larger 5G prototyping effort. Certainly, the first responder community and FirstNet will have their own set of use cases, not too dissimilar from some of the tactical needs of DoD. I think the federal government can be an early adopter in some of the more industrial use cases. Whether it's drones or it's factory automation. I would love to see more prototyping emphasis on those areas to really try and bring those together. And again, can leverage the test bed for experimentation there. I'd say to date, the test bed's primarily been used to test really the control plane security. And I think that's an important thing, but it also has the opportunity to experiment with the management plane, with the data plane, right? Actually testing these industrial applications that sit on top, more than just the sort of control plane interfaces. So I think we're just scratching the surface right now of what we can do with the test bed.
Yeah, it's very exciting. Well, you mentioned MITRE is involved with this FIGHT framework. So tell us a little bit about FIGHT. I mean, that sounds kind of like either a scary thing or a good thing. Tell us a little bit about what FIGHT's all about and what the framework is and how folks should think about that.
Yeah, so I'd say, I'm trying to know the timeline. It was probably 6 or 7 years ago, MITRE really started getting involved with this whole area of threat-informed defense. And the basic philosophy of a threat-informed defense is that you can't build and secure a network to any hypothetical threat out there. It's completely impossible, right? You'd have to shut everything off and just bury it in the dirt. It's the only way to make it secure against any possible adversary. And so we wanted to start prioritizing our cyber defense by looking at what real bad guys were actually doing in real networks and start accumulating that information, building a sort of knowledge base of the tactics, techniques, and procedures that adversaries use to exploit network infrastructure. And then you can better target your defenses. You can build specific defenses for certain stages of the pipeline. You can more readily do attribution because you know the patterns associated with certain adversaries' behaviors. And all that came together, and we published what is called MITRE Attack. And I just want to do a plug. I have my MITRE Attack socks on right now.
Oh.
Superpowers. Yes. I have threat-informed feet. And as the success of MITRE attack really became highly adopted by industry, lots of different organizations are now using it. Most security product vendors are racking and stacking their capabilities against MITRE attack as really a knowledge base and taxonomy for adversary behavior. We started seeing all kinds of other places we could apply the same exact principles. So we rolled out attack for mobile, attack for cloud, attack for industrial control systems, right? And all of these are extending the vocabulary of what attacks look like, what individual steps in the overall attack kill chain might be, and how they knit together. And so the next logical step is 5G, really looking at the 5G core networks themselves and being able to identify with real-world data of actual attacks what bad guys are doing, and then that can help better inform the defense. So that's MITRE Fight, and we just kind of rolled that out, I guess 2 hours ago, one all the way over, and we had the folks from the Office of the Undersecretary of Defense for Research and Engineering there to help us launch it. They're a key stakeholder in the framework, and really soliciting industry engagement because the framework is only as good as the data that underpins it. So the more we can come together and share threat data, the better. In terms of filling out and making the framework more capable. But you can find out more at fight.mitre.org.
There you go. So check it out. We're getting close to the time to wrap up, but I wanted to shift gears a little bit. And as I looked at your biography and your title, you also have this interesting title called Chief Futurist. So on the fun side, when he's not trying to defend networks and come up with the fight framework, you're looking into the future. So for this audience, and since we're the mobile wireless industry, what do you see as the future for 5G and kind of the wireless ecosystem? Where is it going?
Well, 5G is the now, right? So we're already thinking about 6G, and I even have some PowerPoint on 7G if you're interested. But it's interesting. You can start to extrapolate trends from just looking at the history of each generation of mobile technology, and you can start saying, well, each generation of mobile technology needs 70% more spectrum than the prior generation, right? These are huge numbers. By the time we get to 7G, 100% of sub 10 gigahertz spectrum will be for cellular, based on just pure projection, which obviously isn't possible. So there's an obvious need to start investing now in spectrum sharing as a way to really access more spectrum. The spectrum will be needed to accomplish higher data rates, lower latency, and higher densities. So I think we're very interested in spectrum sharing as a key aspect of 6G. And O-RAN is, I think, already paving the way with the radio intelligent controller, the ability to do sensing at the edge. There's all kinds of intelligence that you can bring into the network at the edge that you can use for spectrum sharing. So that's something that we're very interested in. There's also, of course, AI, right? Each network has gotten more and more intelligent, I would say. 5G's gotten to the point where the sheer number of parameters are just unmanageable by humans. And so as we kind of move into, say, 5.5G, 6G, more and more of that network orchestration is going to be taken over by AI. Again, we can start to see that within the radio intelligent controller, the RIC and O-RAN. There's ways you can start to do that within the management layer in 5G's core networks today. But again, seeing that end-to-end AI that's able to orchestrate everything, I think, is another key piece we're going to see moving forward. But also as you look at the application layer, so what's the killer app of 6G going to be? Well, to a certain extent, 6G is going to be delivering on all the unfulfilled promises of 5G, right? I think we have a lot of aspirations to do all this industrial infrastructure with 5G, and the technology is not quite there. And I think a lot of that will catch up as we go into 6G. But I'm also very interested in where we're going with the highest layers of the network stack. So we're starting to see the transition from Web 2 to Web 3, still somewhat nascent, but these decentralized technologies are really taking hold, I would say, in certain parts of the internet. I'm excited about sort of the fundamental shift in how we think about the internet, how the internet's organized, how we govern the internet. There's all kinds of really interesting, powerful, and frightening things happening in that space. Obviously, it kind of gets thought of in the same lens as cryptocurrency, but that's just one kind of early application of this future set of decentralized technologies. So I think about, well, how can we build our 6G infrastructure to support decentralized ledgers as a native app, for example? The sorts of things I think we're going to be thinking about over the next 10 years.
Yeah, really exciting stuff. So, yeah, as you said, today we have 5G is here. It's rolled out to over 300 million Americans. We need more mid-band spectrum. We've talked about that a lot over the conference, right? And we do need licensed spectrum, of course, commercial licensed spectrum. But Dr. Clancy points out there's going to be more sharing as we go forward in order to be able to access more spectrum. So, any last thoughts here for the audience? I think before they head to the bar and so forth and think about all the future of the next decade or beyond?
No, I think it's great to be here, and thank you for inviting us and hosting the event with Testbed. I think it was a great discussion and great partnership, I think, between MITRE and CTIA.
All right, well, let's give a warm thank you and a welcome to Dr. Charles Clancy.